Hi, everyone. Thanks for joining us for this week's edition of Water Talks. I have with me today Vaughn from the city of Regina in Canada. You want to flip to the next slide?
Sure.
Maybe one more click. There we go. Yeah, so like I said, my name is Ryan Brown. I'm assistant engineer with InfoWorks. And I have with me today Vaughn. If you wouldn't mind introducing yourself.
For sure, yeah. My name is Vaughn Wlodarczyk, and I'm with the city of Regina.
And I guess the next slide.
Okay.
So if you haven't been to one of these before, it's a pretty simple concept. We try to keep it open and engaging with everyone who's watching. So please feel free to ask questions. Just pop it in the chat box there, and only Vaughn and I will see it. So please feel free to ask any and all questions. We do have a first question that's already comment on. We can send a link to the recording, but for right now, it's not going to be posted online. So just please ping us if you'd like to see a copy of it. And I think from here, I'll just hand it over to you, Vaughn, for the bulk of the presentation, where we're learning a little bit more about your modeling system-wide stormwater model in InfoWorks ICM.
Perfect. Thanks, Ryan. Like I said, my name is Vaughn Wlodarczyk with the city of Regina, and I'm happy to present to you the citywide stormwater model update for my water talk. Regina is the capital city within the province of Saskatchewan, Canada. And grassland covers Saskatchewan's southern plain. And to the north are the rocks of the Canadian Shield Plateau, coniferous forests, rivers, and lakes. Average precipitation for Regina is approximately 390 millimeters or 15 inches. And the average evapotranspiration is approximately 750 millimeters or 30 inches. While in past decades, no consistent trend in Saskatchewan could be found in extreme precipitation events, it is still expected that their frequency will increase with greater risks of flooding and droughts from greater temporal variability. For the presentation today, I'll give a brief introduction about the project, how the project relates to national efforts, review some of the model development, model applications, areas for continued improvement, and closing discussion. City of Regina, in coordination with ISL Engineering Land Services, Calgary, Alberta office, developed the citywide stormwater model within InfoWorks ICM. In 2017, the city purchased LiDAR data from Airborne Imaging, Calgary, Alberta. The data had 11.5 points per square meter with a 95% horizontal accuracy of 30 centimeters and the 95% fundamental vertical accuracy of 10 centimeters. The LiDAR data, along with the underground storm network, help produce a 1D, 2D urban stormwater model with a minimum element area of 5 meters squared for areas of importance. The city of Regina had collected a significant source of data in preparation and while working on this project. At a later date, the city was contacted by the Canada Water Network to participate in a national project reviewing the use of improved input data for assessing pluvial flooding. This was a perfect opportunity for the city to provide the pre-collected information to the Canada Water Network to use and be a grassroots partner. The modeling results were provided to the city from Canada Water Network efforts and allowed for comparison of the outputs from the city-developed InfoWorks ICM model. The city felt like it was on the cutting edge of the conclusions from Canada Water Network regarding the use of higher quality data inputs as a significant opportunity for municipalities, insurers, and homeowners to better understand flood risk and take action. On the left is the GIS shapefile export of the max ponding depth results from the 1D, 2D InfoWorks ICM model. As a comparison, on the right is the Canada Water Network ponding results in a .tiff format. It was nice to see how well both of these model results compare and provided a gut check to understand where the ponding is occurring during storm events.
So Vaughn, I was actually a little interested in this whole effort by the Canadian Water Network. So are they, is their mission to kind of model like all the cities within Canada? What are they using to model those?
That's a good question. So the goal of the project was not to compare the effectiveness of one modeling platform over another,
Sure,
but to explore the relative changes within individual models when richer data sets are used. And so they undertook an RFP process, which resulted in the selecting of two modeling firms, Jerry Ben Associates Limited and Impact Forecasting. And these firms were tasked with assessing whether incorporating higher resolution digital elevation models and municipal flood defense data into flood risk models reduces uncertainty in the resultant flood hazard maps and compared to the maps derived using current data sets. And they were also tasked with determining what data type, resolution, and format is most effective for improving model certainty. So I think their goal is to have a wider view of each individual city and understanding which data sets provide the most accuracy while still reducing the amount of time required to run those amount of models.
sure, yeah.
Okay, so model development. It was extremely important that a consistent and repeatable process was followed for model development. This led to creation of the modeling standards and standard operating procedures, documents specific to the city's system and needs. The modeling standards serve as a minimum standard and guideline to the InfoWorks ICM platform for all stormwater projects that are conducted for the city of Regina. The standard operating procedures provided internal and external users of the model with direction and instruction on how to use the citywide model and InfoWorks in general. An additional document that was used for tracking progress of the model builds was the checklists that made sure all the parts were developed and pieced together as needed. As model run times for large 2D model regions can be long, the city was broken down into 24 workable regions. These model regions were developed and coincide with the catchment areas for the minor system and or physical divides in the major system.
We did have a couple questions come in. Sorry, I was muted.
Okay, yeah,
and it was a question that I had too. But are those modeling standards, are those, do you guys publish those in some way? Are they on your website or something like that? Because they seem like they'd be useful for other people maybe trying to get into this. And
yeah, I think they're not published as of yet. One of the recommendations from the project was to incorporate those documents in our city standards. So that's still in the process. So
gotcha, they'll be part of like a stormwater manual or something at some point.
Exactly, yeah.
And something, just kind of, I guess, kind of how you use the model. Does the city you collect precipitation data and use that to run and maybe calibrate the model and things like that?
So yeah, we'll get into that a bit later in the presentation, but we do have 6 rain gauges throughout the city that we collect the rainfall data from, and we're able to use that information to verify what size of event the storm was, and then compare that to model results that we've or simulations that we've run in the past.
Okay. And then, so is it just the sub areas that you guys are using, or are you just using those individual sub watersheds, or are you maybe somehow, running the whole thing as one, occasionally, just to see how everything interacts? How's that process?
Yeah, so that's a good question. Currently, what we do, if we need to understand some of that cross-boundary relationship, is join some of the sub areas. So if one of the regions is crossing into another, there's a process within our operating procedure to join the model regions and determine that cross-boundary assessment.
Yeah.
For doing the entire city, that is not possible with the computing power that we have. So,
gotcha. That's totally understandable. Yeah. Got some other questions, but I think I'll let you go on because I think you'll kind of hit them, answer them as we go along too. So,
awesome. So yeah, as mentioned, the checklists were a very important piece just to make sure that we know where we were at with each model region. And so ISL used these checklists to demonstrate which stage each model region was at during development. And using helpful tools such as the import tool within InfoWorks allowed for smooth transition from data editing within GIS to data importing into InfoWorks and performing checks within InfoWorks. The 2D checklist, so the steps leading to mesh generation, were labor intensive and may have been the most time consuming part of the model development. Once the 2D mesh, roughness, and infiltration zones have been finalized and the ground model imported, the mesh generation process can commence. To do so within InfoWorks, you select the 2D zone, then navigate to Model Meshing, Mesh 2D Zone. This will open the Mesh 2D Zones window. There are options to add voids, break lines, and walls in this window. However, they may only be needed in specific cases. Depending on the desired density of mesh elements and other factors such as computational power, spacing between polygons, and small unseen gaps, the generation time can vary significantly. If the process takes a significant amount of time, it is recommended that some of the polygons are simplified further to improve generation. The progress of the mesh generation can be viewed in the job control window. So these 3 model applications are only the tip of the iceberg when it comes to using results from InfoWorks modeling. They are some of the key applications that have been used by the city to help develop business cases and prioritization of work efforts. They include ponding mapping, pipe results, and ponding scoring, and will be discussed further in the next few slides. So here is an example of a residential ponding location. In the back of the image, you can see water is breaching the banks of the road right of way and is adjacent to a property. Where the lady is standing correlates well with the deepest location within the ponding map. This is one of the underpasses within the city that regularly fills with water during storm events. As it is difficult for some vehicles to know how deep the water is, and that is unpassable, leads to rescue efforts from emergency services.
We did have some questions come in just about, kind of the process you guys went through for building these models, and how big was the total model? How big were these sub models, and was that kind of driven, I guess, on run times and what was practical?
Okay, yeah. So overall, the population of Regina is only 230,000 people. So not sure exactly what the land area encompasses. But yeah, they were broken down into those areas for ease of model runtime and producing simulation runtimes that are a bit more reasonable on the computing power that the city has.
Gotcha.
Can you repeat the question again?
Just if there was, if you had any idea how big those sub watersheds were.
Okay. Yeah, I don't have an exact number.
Have a number.
Really right now.
And then with the 2D mesh, did you guys just blanket you used it everywhere, or was it approach of developing the 1D, seeing where problems might be, and then kind of going back and adding in?
Yeah, good question. We did the blanket approach and used it everywhere.
Okay.
But yeah, there are other approaches there where you could do the 1D and see where you have problem areas, like the one shown on the map.
And I know there's a lot of kind of philosophy out there as far as what you should do, and start out with something simple and move to something more complex. I mean, and that's certainly warranted in certain places. I haven't experienced those types of problems with ICM as much. If you have a clean model and stuff like that, if you have a good operating procedure, like standard operating procedure, like it sounds like you guys have, you may not run into those side issues. Do you know the total node count? And you did mention at least the minimum size of the mesh. Did you use any of the terrain sensitive meshing or anything like that, or have any idea of the average cell size?
I'd have to look back into the model to get those numbers for you, but for the city of Regina, or for the underground network, it was a one-to-one relationship. So we had included all our catch basins and manholes as nodes. So fairly substantial amount of nodes and links. And then, yeah, average mesh size, I'd have to go back and check.
Gotcha. And then just something about time steps. I can answer some of this too, but I'm guessing you guys just use the default time step, and then it's, yeah, so in ICM, the time step is variable, so it will change depending on whether looking for that stable condition in the model. So typically, there's not a lot of decision making when it goes into determining the time step that you use, since it is very dynamic and very stable. And then, did you guys model the pipes as, just assuming they were clean? And I guess along those same lines, was there any kind of calibration process, or was it mostly the validation?
Yeah, so it's assumed all the pipe network was clean, and the only, no calibration process as of yet, just the validation with the historical rain events that we've had.
Gotcha. Yeah. That makes sense. And then just lastly, while we're on questions, okay. Is it a separate sewer system or a combined sewer system?
For the most part, it's separate. There are a few cross connections here and there, but gotcha. Yeah, Regina is young enough that it did not have
yeah, it's not
combined sewer system.
Gotcha. All right. Well, that's pretty much it. So let's keep going.
Great. Thanks, everyone, for the questions. Keep them coming. Okay. So this is an example of implementing proposed improvements. We can compare the existing conditions to post-relief conditions. This relief option was looking at implementation of a detention pond located in the green space in the top right corner of the image, with relief piping extending to desired ponding locations. Due to elevation constraints, some ponding locations remain even post-implementation. So this is relates to pipe results. Pipe results such as flow, velocity, and surcharge state are attributes that can be used for a variety of analysis and prioritization. From this image, it is possible to see erosion and sediment deposition at the outlet of two storm trunk mains. So implementation of sediment removal prior to the outlet of these pipes may improve maintenance activities and be beneficial for the receiving water body. To determine which ponding location is of higher priority, the city had ISL create a GIS toolbox using InfoWorks ponding maps as a key input. Generating ponding scoring over a range of storm events allows for an average annual risk score to be calculated. It also allows for determination of risk reduction and residual risk with implementation of improvements. The ponding scoring was applied as such. For ponding touching any building, 1 point was assigned. For ponding touching any building that contains a residential class code, 5 points are additionally assigned. For ponding touching any building that is of a critical structure, such as schools, hospitals, or emergency services, 30 points were additionally assigned. For ponding touching any non-residential or non-critical structure, 1 point was additionally assigned. For ponding within 250, 500, 750, and 1,000 meters of a school, so proximity to the school, decreasing points were additionally assigned as you got further away from the school. And any ponding within a arterial, collector, or local road, points of 10, 7, or 2 were additionally assigned, respectively. Overall, this exercise has been very useful and could not have been possible without the detailed ponding maps developed through InfoWorks. Areas for continued improvement. So the citywide stormwater model should be reviewed and updated after significant periods of growth, or every 5 years to update the model with any capital upgrades completed by the city and the most up-to-date growth plans. Consideration for the purchase of new LiDAR data should also be made around these timeframes. This could provide clarity on planned location of development, the density of the proposed development, and the potential corresponding upgrades. This should also be undertaken when considering densification within the established area. One area of improvements that we may need to look at is inventory of our catch basins, just to make sure that we have the correct size for inlet capacities and make adjustments for and improving the accuracy of the model based on catch basin inlet capacities. Continued assessment of rain events and ponding locations, verifying the existing conditions within the model. And then as well, ensure we are taking full advantage of the software, just continued use and use of available tools.
So one question that was a bit earlier.
Yeah.
I'll get to this in a second, but
Okay.
with the SOP that you guys put together, was there collaboration? Did you guys look to other cities as examples or incorporate anything like that?
Yeah, definitely. I think we probably tailored ours based on other cities such as Toronto, and that's a good background and procedures with their modeling work that they've done, and use bits and pieces from other areas as well, but try to tailor it to the city of Regina and how we plan to use our model.
Sure. And I should mention too, well, like one, we've got a lot of good resources for, best modeling practices in ICM and things like that. I have put together, and it's kind of based on other kinds of checklists that I've seen, as well as our own knowledge base about, just good things to think about whenever you're you're doing this type of modeling in 1D and 2D. And so, I'm more than happy to send that over to anyone that would be interested in that for sure. So,
yeah, I'm sure the modelers that were in the thick of it when they were developing it were definitely using all those pieces and tools that are available.
Right, and it really goes through everything from like data integrity to things you should just look out for that might be a little bit different in InfoWorks versus another 2D or 1D modeling software. This last slide kind of hits on some things that I think you maybe mentioned as far as being able to update your model, just as far as something we've done at Innovise. I think if you click again, it'll bring it to full screen, Vaughn. If you just click on
to play the video, or
just click on, like, if you're to progress the slide, I think it should.
Okay.
It should go. Maybe one more time. No, I guess there's a.
Yeah.
You want to bring it full screen? There's a.
Okay. Is there a button for that?
Over on the right side. Yeah. Anyway, I can just describe what we're doing.
Okay.
So we have another product called Info Drainage that's really designed for that's really geared toward design work rather than like the planning and analysis that InfoWorks is used for. We do have a direct integration to InfoWorks ICM. So if you're developing a project in a small development or something like that in Info Drainage, you can import that into your InfoWorks ICM model and kind of maintain that model instead of every few years or something like that, updating your model. But at the same time, that there's also, it kind of comes down to philosophy that if things aren't changing in your watershed that much, it's probably not going to change all that much with the results. So there might not be reason to do that, but that capability is there as far as helping that streamline a little bit more. We did have a bunch of questions come in. So when you were developing the model, did you go through different kinds of build out scenarios? Was there any future scenarios or predicted growth that you put together and analyzed?
So for this, we were more so looking at the existing system and not really at the new boundaries, but we definitely provided the model as is to our team that does look at growth areas. At one point, we ran some simulations to determine how much water was transitioning from an existing area to a new development area for them to understand how much water they had to handle as the new development. But there wasn't as much growth scenarios applied for our purpose.
I guess that kind of relates because I mean, I know like in some cities there's different kinds of like zoning requirements essentially that make you kind of densify your city versus other that might be a little more sprawling and unpredictable. So having those growth plans can be good. As far as minimum pipe size, what were you guys analyzing there? Was it down to 12 or 15 or? I guess your own metric.
Metric. So
yeah,
we do have some pipes that are 100 millimeters or 150, but for some pipes that we didn't have diameter sizes for, we assumed 250 millimeters.
Okay, so that'd be roughly 10 inches. That's pretty small.
Yeah.
I'm assuming you did, but this is a good question. But GPU enabled for the 2D simulations. I know when you first build a model in InfoWorks, and actually in the next release, I was just talking to the product manager that when you first build a run in InfoWorks ICM, that never is always the choice for the GPU, and they're going to switch that default to F applicable. So did you guys use GPUs for your?
We did, yeah.
Okay. And I guess along the same lines, what was the rough runtime for some of these simulations?
Yeah, so when the consultant was running them, they're running them a lot quicker with the GPU. So a couple of hours maybe.
Okay. Average. Now, this is kind of a long question. I'm just going to read through it verbatim. What is the average depth to groundwater, and has any consideration been given for the implementation of green infrastructure to distribute infiltration throughout drainage areas? So I guess just about, is there any groundwater impact? I can't imagine in the plains areas of the North America there'd be a ton of that, but can you speak to that a little bit?
Yeah, I would say the city of Regina is maybe on the tail end of green infrastructure and has a lot of catching up to do in that regards to applying some of those practices. And yeah, I think there's definitely opportunities in a few locations where you could distribute the ponding from a residential street to a nearby park. We notice a lot of our park areas are, for some reason, at a higher elevation than the residential road rate. So trying to maybe cut out and lower some of those park areas to distribute the water back into the natural grass areas would assist in that nature.
Yeah, like almost using. I've seen a lot of that. Cities with greenways and things like that they'll kind of use the floodplains for recreation and then flood management when it's pouring down rain.
Yeah.
I guess in this makes me think of some other questions, but somebody asking about some using radar rainfall. Did you guys use historical events for some of those ones that you were maybe validating against, and some of those pictures you were using? Maybe they weren't like perfect calibrations, but did you guys use any of those events?
Yeah, we haven't gotten into the radar rainfall as of yet. I'd be excited to try it out and keep advancing the model in that form. Done a bit of reading on it and need to do a bit more assessment of how we could incorporate that with the model we have now. But for now, we just use the historic rain events and the rain gauges that we have within the city.
Gotcha. So we get another good question, and I hope I understand it. But just curious about the level of service you're measuring against. I guess, is there like a certain storm event that you're trying to protect against? Is there I would assume there's certain standards. I mean, you had different points for collector and arterial roads versus residential flooding and critical facility flooding. But
that's a good question. And in general, for the existing areas of the city or the older areas of the city, we're trying to get our major system for a 1 in 25 year event. And for new development, we have our major system as a 1 in 100 year event.
Oh, wow.
But then when we look at our ponding mapping and that ponding scoring idea, there's a bit of a difference in, okay, it's a 1 in 25 year event and there's ponding happening there, but is that ponding actually impacting buildings and residents? If yes, how badly by scoring it? And if no, then is it something we need to actually address? So having that, yeah, it's a 1 in 25 event, but it's not impacting, then let's not address it. But if it is, what are some options to address it?
Yeah. So some of those like new developments, they have to mitigate against the peak flow from a 100-year event. Is that what you're saying?
Yeah.
Wow. That's nuts. I mean, it's great, but
and yeah.
Along those same lines, what is a 100-year event look like in
Regina? Yeah, I have to double check what the depth of water is. It might not be as big as some other numbers that you've seen in the past, but our 25-year event is 95 millimeters for the 24-hour, I believe. So
it's not too bad. I'm located in the southeast U.S., so we've got like, in the 10 to 15 inches and stuff like that. So that's what I'm used to.
Yeah.
What was the methodology? How was that determined for the scoring? Was that just solely dependent on the consultant's kind of opinion, and then based on, of course, your goals, or how's that?
That scoring was actually more developed internally with our asset management team. Just had a kind of a sit-down brainstorming session, and just to get an initial feel of some numbers. Those numbers haven't been solidified and saying this is what we're using and advancing it that way, but I think there's some options for adjustment if need be for different some of the scoring ideas, but for now it provides a relative scoring from one ponding location to another, and I think that was the main outcome, is just to know which one is more important than another.
And then just tweaking the scale, which I think is a fantastic methodology when you're approaching this type of work, where your asset management is like a constantly evolving thing, and to make it flexible is great. So you mentioned you had 6 rain gauges throughout the city. How did you aggregate that information to use that within the model?
And yeah, actually we've used that information more so on our wastewater model, which is citywide. So versus these area models, we just use our standard rain event. So I may have misspoke previously. We use the rate and fall data more so for our wastewater model.
Okay.
They're aggregated by area, versus our stormwater model. We use just the standard
the design events.
Rainfall through design events. Yeah.
Gotcha. And then it sounds like you guys are being aggressive as far as climate impacts and climate change by requiring these new developments to meet the 100-year event. What were there any considerations in the development to try to mitigate against some of those as storms do become more intense?
That's a good question.
I know it's different for different places in the country or in the North America.
Yeah, I think there's some future projects like our drainage plan update that will look at the climate change effects of our IDF curves and things like that. But yeah, for this project itself, there wasn't any looking at climate change impacts. But yeah, it's definitely a piece that we'll be able to play around with when we do advance our drainage plan update.
I guess so. You did mention about the size of the city, but what was really the level of effort? How long did this whole process take, and maybe some of the costs involved and things like that?
Yeah. So yeah, we started that the LiDAR data was flowing in, I think October of 2017. And we wrapped up the project 2019, maybe mid 2019. So about a year, year and a half of work for this project. And so yeah,
that was the whole like model development and validation and things.
Yeah, exactly. Yeah, just going through all the area developments and then the validations, and also reviewing the standard operating procedures and guidelines. Yeah.
And I think this is somewhat similar to the previous question that we had about groundwater. And I guess I'm not totally sure where this question's coming from, so maybe some more context from the person who asked it. But any kind of consideration for the amount of infiltration into aquifers? I don't know if that's maybe like a water security question. I'm assuming you guys use groundwater for your potable water system.
Yeah, we're actually surface water. We have a lake that we pull our water from, so there's no consideration for the amount of water that would be transitioning to some of the aquifers in the region.
Gotcha. And another question about just the cost of modeling, but I do want to clarify one thing of did you say you used LiDAR data for the ground model? Okay.
Mm-hmm, yeah.
I know a lot of the latter areas might use photogrammetry. I don't know. I've forgotten the word now. You know what I'm talking about?
I think so, yeah. Where you can pull the elevation off of the air photo.
Yeah, basically. Yeah, there we go. Thanks, Justin. Photo grammetric. I guess that's how you pronounce it. Yeah. Photogrammetric. Yeah. So anyway, back to that. It's so what was the rough cost of like the modeling effort?
Yeah, so overall the project cost was $475,000.
Assuming that's Canadian dollars.
Right, yeah, Canadian. Yeah. And the LiDAR. Yeah, what's the exchange rate these days?
I don't remember. I'm pretty sure it's close to 1 or 1.1 or something.
Right. Yeah, okay. And the LiDAR portion was maybe in the 40 to 50,000 range.
Gotcha. That's kind of it for the questions. I do want to say I really appreciated. That was a really neat look at the, especially like the velocities and the flows coming out of some of those pipes where they're extreme, and seeing that evidence of the sediment being pushed out and things like that. I guess along the same lines, are you using it all? I mean, it sounds like you are to help with some of the asset management aspects of things. Are you incorporating that into those plans as well? I think. How often should we clean things out? How often? Okay.
Yeah, no, we are definitely trying to incorporate that for cleaning programs and our CCTV and relining programs as well. Our wastewater side of things, they're fairly advanced with the amount of CCTV and cleaning that they've performed. The stormwater side of things is the pipes don't corrode as easily, so they're in better condition and better shape than our wastewater. So it's starting to pick up, though, I think, on using some flow information to prioritize which pipes should be cameraed and assessed more regularly.
Is there any, I'm just trying to think, is there any way of being able to monitor for like culvert failures and things like that? Are you able to use that information for stuff like that?
Yeah, potentially for sure. Yeah. You think that the water level should be at a certain height, and you're only getting
Right,
a
yeah.
different elevation on one side versus the other of water, then you be questioning what's happening on the culvert itself and getting a bit more into the details there.
Yeah, I guess like customer complaints too, and aren't matching up with what you're seeing in the model and stuff like that. Sure.
Yeah, exactly.
Okay, that's really all I can think of. I know we're a little bit early, but you know we can call it here. If there's anything else you want to wrap up with, Vaughn, we really appreciate having you. I thought it was a really interesting look, especially with stormwater. I love stormwater, so love to get to hear these stories.
Yeah, no, it's a pleasure to present this information. It's my first time doing a presentation like this, so I'm looking forward to getting more opportunities like this and sharing the information that we have and advancing our stormwater system.
Yeah, great. And everyone who popped it into the chat with about that 1D, 2D checklist I mentioned, I'll be sure to email that over. So thanks everyone for joining. I'll go ahead and end it here then.